For centuries, we have modeled the pursuit of knowledge on the architecture of the cathedral, a series of isolated, walled-off towers designed to keep different fields of study physically and intellectually separate. This separation is codified through the academic discipline, a specialized branch of learning defined by its own dedicated faculties, its own peer-reviewed journals, and its own learned societies. But while universities are organized into these rigid, non-communicating boxes, human knowledge itself exists as a single, heavily interconnected web. To understand how higher education functions, we have to look past the stone walls and examine how disciplines partition reality to create internal theories. The future of research and problem-solving now depends on our ability to navigate across these structural boundaries rather than remaining confined within them. These academic divisions function as a primary filter, shaping the specific ways the academy chooses to organize and interpret the world around us. This taxonomy maps the entire landscape of modern inquiry. The university partitions human knowledge into 5 primary domains: humanities, social science, natural science, formal science, and applied science. On one side, we categorize human culture and philosophy within the humanities, while the social sciences develop frameworks to analyze collective behavior. The remaining 3 domains focus on the mechanics of reality, the physical laws of the natural sciences, the logical systems of the formal sciences, and the technical translations of the applied sciences. This system is inherently hierarchical. Each of these broad domains continually fractures into hundreds of hyper-specific subdisciplines. The structure of the academy encourages practitioners to move downward into these branches, becoming increasingly specialized and increasingly isolated from the fields next door. While this specialization ensures a deep focus on micro-topics, it also structurally removes researchers from the broader context of the world. We can see this in practice by following a single branch. We move from natural science down through physical science and stop at the silo of physics. Even within physics, knowledge is further partitioned. We push even deeper into the subdiscipline of quantum mechanics, a field isolated at the very bottom of the taxonomy. At this level of specialization, the focus is incredibly narrow. Scholars gather around specific instruments to observe a tiny fraction of physical reality. This creates an extreme depth of knowledge regarding atomic structures, but that expertise is confined within the silo, separated from any neighboring application. This intense isolation raises a central question. How does this narrow focus change the way a discipline views the world compared to neighboring fields? Moving between these academic silos requires more than just a change in subject matter. It requires changing the fundamental rules used to validate truth. To see these internal mechanics in action, we leave the natural sciences for the social sciences. Every discipline utilizes an epistemological lens, a specific theoretical framework used to filter and interpret raw data. Sociology provides a clear case study, as it explicitly divides its inquiry between 2 primary internal lenses. The first is macro-sociology. This wide-angle lens views the world in terms of large-scale systems, examining how institutions and society-wide patterns influence behavior. The second is micro-sociology. This magnifying lens ignores the large institutions to focus on small group dynamics and the individual interactions that create personal meaning. In this way, a discipline does more than collect objective facts. It dictates the specific scale at which those facts are understood. Consider this dataset: a group of young men working at an industrial wool carding machine in the early 20th century. A scholar applying the functionalist perspective, the first of our macro-level lenses, will extract a narrative of cooperation from this image. This theory views workers and machines as interconnected parts of a larger system, working in balance to support the stability of the broader society. But if we switch to the conflict perspective, that cooperative narrative disappears. This viewpoint, championed by Karl Marx, ignores social balance to look for something else entirely. Through the conflict lens, this same factory is a site of struggle, where different classes compete for power, resources, and control. Finally, we can swap these large-scale views for the interactionist perspective. Now, the massive institutions and power struggles fade away. The focus shifts to the micro level, the labels the workers give one another, and the symbols they use to navigate their daily interactions. Each of these theories extracts a different truth from the exact same image. They serve as the structural filters a discipline needs to organize reality into something it can measure. When we pull back to view the whole academy, we see sociology standing isolated alongside biology and economics. This isolation creates a breaking point when the world faces a complex crisis, like a global pandemic or environmental collapse. Because the crisis spans multiple domains at once, these vertical silos often fail to share data or overlap their methods effectively. Traditionally, the academy tried to address this through multidisciplinarity, experts from different fields working side by side while keeping their own isolated frameworks intact. However, addressing a modern crisis requires more than just proximity. It requires the fundamental integration of the epistemological lenses themselves. True interdisciplinarity is the aggressive integration of content, methods, and ways of knowing across these boundaries. This requires experts to synthesize their distinct perspectives, combining their data to construct entirely new frameworks. We see this synthesis in the field of environmental sociology. Here, the sociological study of human institutions is fused with the applied science of environmental engineering to address the root causes of ecological shifts. This approach preserves the rigor of traditional fields while connecting their isolated data streams into a functional network. The traditional academic model has served as a highly effective organizational tool for centuries. These departments provide the deep, specialized theoretical lenses we need to extract complex data from our world. But relying solely on these isolated silos creates systemic blind spots in our understanding of the whole. As we look toward the future of the academy, the original blueprint of the university is beginning to shift. The rigid vertical taxonomy is evolving into a dynamic network, a system where information moves horizontally across every disciplinary boundary. The future of research, the future of policy, and the future of technology now relies on this model of connected learning. The most significant intellectual breakthroughs of our time now emerge directly at the intersections where different fields collide.